Okay, what if we apply the ideas of limits that we learned together with the idea of the tangent line problem to a very well-known graph for a function? So this is f of x equals 2 to the xth power. So that's a function whose y value doubles every time x increases by 1, right? So the value for x equals 2 is double the value for x equals 1. The value for x equals 3 is double the value for the previous one. So every time we're doubling the y value. Okay, so how would we use these ideas? We know more or less what the graph looks like. We learned how to graph this already, I'm assuming you do. And the point we're looking for the tangent line at is 0, 1, which is this point right there. So there is some tangent line that exists in there, whose equation I don't know, but it's there, it lives there. And I'd like to find the slope of that line, because if I do know that slope, that's the line that touches right there, right? If I do know the slope of that line, since I already know one of its points, I could easily find its equation fully. So let's concentrate on the slope for now. So as you remember, we discussed the tangent line problem before. We're going to find the slope of the tangent line by finding 2 points, finding the equation of the secant line, so that will be your point 0, 1, and then another point, whichever one it is, x, comma, f of x. And we're going to do change in y over change in x, so that will be f of x minus 1 over x minus 0. And then this is the slope of the secant line. The slope of the tangent line is the limit of that as x tends to 0, as x approaches 0. So that will be the limit of f of x minus 1 over x as x approaches 0. And that will exactly be f of x, we know, is 2 to the xth. So that's the limit that we end up with, and that's what I have at the bottom there. Now, this is a limit that is a little difficult to handle using the techniques, basic limit techniques. In a calculus class, you will definitely learn better techniques that would allow you to find this. But for now, I just want to try and use a table to see what we are expecting from that limit. So all I do to fill in this table is I plug in certain x values that are closer and closer and closer to 0, right? Because x is approaching 0. And then just as an example, so you can get what I'm looking for, the first value is 0.1. So to get that 0.7177, I do, right, open parentheses here, you see my calculator on the left. I do 2 to the x power, so that would be 0.1. So there's the exponent. Minus 1, close parentheses, and that's divided by 0.1, which is x. Right, so this is me plugging in x equals 0.1. I can see my answer in decimals. That's 0.7177, which is exactly what I have here on the right. And the smaller, as I change the x value on that calculation, I get a value that's closer and closer to some 0.693-ish, right, as you can see there. But if I remember from previously studying logarithms, the ln of 2 is also approximately a 0.693. So it is a working hypothesis that the limit equals to ln of 2. So this is an idea, so an expectation that we can have. We're going to see when we study more complicated limit techniques that this is actually true, but for now, just to keep this in mind. So this is a GeoGebra construction of the case we were studying just now. This is y equals 2 to the x. This is the green graph you see on the line. And I'll slowly reveal what the left sidebar items mean. So first I show you item point A, which is 0.1, or 0, 1, excuse me, which is the point where I want to find the tangent line for. t for me is going to be some number that goes between -2 and 2. Could be any number. And based on the t value, I can find another point, right? It's t comma f of t. So that's point B. So if I move t, B moves with it, right? So what I do next is I find a line connecting A and B. So that's going to be my secant line. And as I make t smaller and smaller and smaller, the secant line is going to approach the tangent line that I actually want to find, right? So I move it over to the left there. Or if I am on the left, I can move it over to the right, whatever. Just gotta notice that if I make t equals 0, then that means I'm finding a secant line between 2 points which are the same point, and that's undefined. You can see the slope there, right? And then the slope of the line, as you see, if I reveal that too, m, right, as I get closer and closer, let's get close to the 6, 9 that we're looking for. Right, it's very, very close to the 6, 9. The closer I get to 0, if I let that animate on its own, you can notice that. Another thing we can do is to actually draw the tangent line that we would have if we assumed that the slope was ln of 2. The slope of the tangent line was ln of 2. So if we do the tangents, the point slope formula for that equation, we would go y minus 1 equal to, and then the slope, which we know is ln of 2, so ln of 2, so that's, actually I'll erase that because I don't want that 0.93 in there. Just doing ln of 2, so that's the slope, and then the x minus 0, right? So that's the point slope because 0.0, 1 is my point, and the slope is ln 2. That's the point slope equation of the line that I think is the tangent line. So I hit enter. So that's the other equation. I can maybe change the colors for this so that it looks a little bit more pronounced. So I'll make it red maybe. And now you can easily see that this black line that's moving as t moves gets closer and closer to the red line as B approaches A. So in fact, it does make sense to assume that this red line is the tangent line at A. We're going to find that once we learn more techniques. But so far, this is a good taste, a good first glimpse of what happens.